In this lesson, I explore steganography, a method of hiding data. You can download the script for this video above or at the end of the video. Steganography is a form of data hiding. It hides information within media like graphics or audio files. This is a form of information resource obscurity. It should not be used as a data safeguard because obscurity is not security. However, threat actors sometimes use it to hide data extraction. Most organizations do not pay much attention to video or audio files that might contain stolen sensitive information. Before moving on, it's important to understand that steganography is used for some business purposes. Watermarks, for example, are a form of steganography to later prove the authenticity of a document. Let's start by reviewing how graphics are created. The building blocks of a graphic are pixels, as shown in this graphic. The pixels are the smallest squares in the exploded section on the right. Each pixel is colored in such a way as to create an image. As the number of pixels increases, resolution of the image increases. More pixels also determines how much data we can hide in a graphic. The exploded image was created with a graphics app that shows transparent pixels as dark gray. To demonstrate how pixels are created, I'm going to use the basic RGB or red, green, blue color codes. Each pixel is represented by 3 bytes. Each byte controls the pixel's color. This graphic shows the values for red, green, and blue. Red hues are controlled by the first byte, green by the second, and blue by the third. This shows how we adjust the RGB byte values to arrive at a specific color. By adjusting these values, we can arrive at any of thousands of colors. A steganography algorithm inserts data into a graphic by replacing the least significant digit in each pixel byte with a bit from a character bit, as shown. Note that the pixel color does not noticeably change. This is why it's possible to hide information without anyone detecting it. In this example, I used this photograph in JPEG format. I used the online steganography tool at the QR code shown to insert about 2,000 characters into it. Notice that there is no noticeable difference between the unmodified and the modified photo. It changed the size of the original file, however, from 247K to 1.3 megabytes. Here I used the same original photograph, but I inserted 10,000 characters into the photo. It's still very difficult to see any change in the graphic, and the size of the modified photo is not bigger than the photo with 2,000 characters embedded. The amount of resolution retained can depend on the steganography approach used. Threat actors can hide information in audio, video, and graphics, and then extract the data without detection. This is also a great way for insiders to steal information. Many steganography tools also enable encryption of the hidden data that is protected with a password. One of the best ways to prevent this is to prohibit the installation of steganography tools. The best approach is prohibiting users from installing any application not on the approved app list. This also helps prevent the installation of any malware, including steganography. Of course, all anti-malware efforts also help keep malicious tools off the endpoints. However, there's never a guarantee that anti-malware will be 100% effective. And we can detect steganography activity by looking for unexplained file size changes. Related to this is requiring a hash value for every graphic, or audio, or other files that might be used for steganography. If the hash value changes, security knows the file was changed. However, requiring hash creation for every file is likely not practical. Network behavior and analysis and other tools can detect the types of files leaving the network. If the number of audio, graphics, or video files leaving the network exceeds established baselines, it's very possible someone is using them for data extraction. Well, that's it for this lesson. If you have questions, please ask. And until next time, be careful what you click.